Today we're going to talk about time zones. Now, in order for us to understand time zones adequately, we got to understand a little bit about longitude. Now, latitude and longitude is going to be another video, but longitude lines are those that are vertical lines stretching from the north to the south pole or the south to the north pole and coming back on the other side as a totally different meridian, that is, line of longitude or vertical line on a grid. Just a quick note about latitude. Latitude goes up to 90 degrees north and 90 degrees south. And when you're at 90 degrees north or south, you are at the north or south pole. But longitude lines are actually 180 degrees all the way around. Let's break it down. When you look at longitude lines, you start at the prime meridian, just to make it simple, all right? Now, the prime meridian is gonna be the 0 degree line of longitude. There is no east or west value with the prime meridian because the prime meridian is just it. In order to understand time zones, we have to understand why standard meridian is. So every single line of longitude could be placed onto a grid system on the globe. But what you normally or may very well see on most globes or mini maps is the standard meridians, those that are 15 degrees apart from one another starting from the prime meridian. So you've got 15 degrees east, 30 degrees east, 45, 60, so on and so forth, and also those same values to the western hemisphere. So if you think about 15 times 12 equals 180 degrees, and that's the opposite side of the world from the prime meridian, and also is simply gonna be 180 degrees longitude. There is no east and west value there as well because, well, you're on the edge, if you will, of the two hemispheres. So where do time zones come in? Simply, time zones straddle each of the 15 degree lines of longitude, these standard meridians. So if you have the prime meridian, the time zone for the prime meridian area is gonna be 7.5 degrees east to 7.5 degrees west. So you literally will have the time zone cut off in between the standard meridians. And this is how you measure the time zones. And so just like there are gonna be 24 standard meridians, there will be 24 time zones, each one representing an hour of the day. Let's pretend that the time is 12 o'clock a.m. on the prime meridian. Now, if it's 12 o'clock a.m. on the prime meridian, you are at the same time all over the world. Like, we're not looking in the future, so what time would it be if I was talking to my cousin in France? What you would do is you would look at the map and look at the different time zones, and you would actually measure out and add an hour for every single time zone you moved towards the east in the direction of France. Now, I'm in South Carolina, so you would count out 1 hour for every single time zone that you moved until you got to the same time zone as France. Since it seems like they're ahead of us, going in the east using time zones is referred to as fast time. So every time you increase a time zone by going east, you increase an hour. That doesn't mean you've moved an hour or the day has moved over an hour. It simply means that they are 1 hour ahead of you at the same time. So if it's 12 o'clock a.m. right now in South Carolina, then the next time zone over would be 1 o'clock a.m. and the next time zone 2 o'clock a.m. and so on and so forth. If you're going towards the west, you actually are taking away an hour as you move further west. So they call this slow time because it is as if you are ahead of them, and so they are behind you, and this is how fast and slow time is factored in the time zones. So looking just in the United States, you've got 4 different time zone areas. Let's pretend that I am in California and I'm traveling back home after a long spring break vacation. It is 12 o'clock a.m. in California. What time is it gonna be back at home in Columbia, SC? Well, you would go over 4 time zones from the current time, not adding any time because of travel or whatnot. It would be 12 o'clock in California, 1 o'clock, 2 o'clock, 3 o'clock in South Carolina. And there you have traveled across the time zones of the US. Now, what if we were talking about what time would it be upon our arrival after we left at 12 o'clock a.m. from California? Well, let's pretend that it takes us 10 hours to fly to South Carolina. I'm not sure, I've never flown, so I don't know. Let's pretend that it does. So not only would you factor in the time zones and it be 3 o'clock at the same time as it's 12 a.m., but after you've factored in the time zones that you'll cross over to get to South Carolina. You then have to factor in the 10-hour flight. So you add 10 hours to that, and it's looking like it's gonna be 1 o'clock p.m. before you arrive in South Carolina. Not to confuse it too much, because right now it seems pretty basic and pretty simple. But let's pretend for a second that we've crossed the international date line. What the heck is that? Remember when I was telling you guys about the 180-degree line of longitude opposite the side of the world of the prime meridian, which is a 0-degree line of longitude? Well, that's the international date line. The way it works is when you cross it going fast time, so if you're going to the east and you cross the international date line, whatever the day is, so let's say that it's April the 13th when you cross the international date line, it goes back to April the 12th. You literally will go back to the previous day. Now wait a second, no, you didn't just go back in time. It all makes sense, you see. If you go towards the west and you're going slow time, and you're crossing the international date line going slow time, then you will actually +1 a day going across the international date line, so that if it's April the 12th, then it will be April the 13th after you've crossed the international date line while going west, because you add a day. Let's make this make sense. I prepared an infographic for you in preparing this video about time zones, so I can help to demonstrate to you what the time zones actually look like if you're looking perhaps at a map. And also I wanted to explain to you guys how the international date line works. This infographic that I made is going to be in the description for this video, so feel free to take a look. Now let's dissect it. If you look here, I've said a 1,000 times now that we're going to make the prime meridian be 12 o'clock a.m. Now, if you're going from the prime meridian and you're going towards the east, which is going to be fast time, then you're going to go then if it's 12 a.m. on the prime meridian, it's going to be 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, 5 a.m. The further you go, it seems as if they're in the future. They're not, but that's how fast time works. But when you cross over the international date line, you are going to subtract 1 day when you cross the international date line going in the direction of east. Now, if it's let's say April 13th, right, over here, then when you cross the international date line, it is all of a sudden going to be April the 12th. Now, how is it that this is the case? Why, how, when, what, where? Well, let's explain. If I am at the 90-degree mark, okay, the 90-degree east longitude mark, and I'm going across the international date line to a place that's located at 135 degrees west longitude, then here's where it's going to go down. I'm going to cross over 1, 2, 3, 4, 5, 6 time zones, and then 7, 8, 9. So they're going to be 9 hours ahead of me. So if it's 12 o'clock a.m. at the 90-degree mark, then they are going to be, we just said 12, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9. And so it's going to be 9 o'clock a.m. at the 135-degree line of longitude, if it's 12 o'clock a.m. over here. So we had to have taken away a day because it was April 13th, and it's going to be April 12th over here at the same time as it's April 13th at 12 a.m. here. Now, how does this make sense? Well, let's trace it back going to the west and see what happens. So if it's 12 a.m. here and 12 a.m. is midnight, that's the beginning of the next day. So it's April the 13th, 12 a.m. at 90-degree east longitude. It is 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, all right? And then 12. This is 12 p.m. 12 p.m. April the 12th. 11, 10, 9. Hey, guess what? It's 9 a.m. April the 12th. So if that doesn't get it to you or help you to understand it, then I'm not really sure what does. Now, let's pretend for a second that you're going, again, from 90 degrees west and you're crossing, 90 degrees east, and you're crossing the international date line, going in the direction of east to get to where it is at the same time, 9 o'clock a.m. at 135 degrees west longitude. But it takes you 10 hours to do that. So, not only would you factor in the time zones and the loss of a day, but you would you would then add 10 hours to that. So it would be 9, 10, 11, 12, 1, 2, 3, 4, 5, 6, 7. It's going to be 7 o'clock p.m. on April the 12th. Alright, so I hope that clarifies what it would look like if you saw this on a map and had to actually apply this information. Let's answer some questions. I hope you liked my video about time zones. I hope you find it informational. Thanks for your time, energy, and effort. Like, subscribe, share, bam!